go. Here we go, here we go. Here we go, here we go. Here we go, here we go, here we go, here we go, here we go. Here we go. Here we go. Here we go, here we go, here we go, here we go. Here we go. Here we go. Here we go, here we go, here we go, here we go. Hello and welcome to Containers from the Couch. I am Justin Garrison, and I have a full couch today. This is awesome. We have a couple of guests, and Sutel's joining us again. Wrong arrow for my hands. So we are going to jump into IPv6 on EKS. But first, let's go around and talk to everyone. Sheetal, you've been here before. Go ahead and say hi.
Hi, hey guys. I am Sheetal Joshi, as you might already know, and I'm on EKS team. And today I'm excited to bring you IPv6 on EKS, and joining with me, we have Mike and Aproop here on the couch today.
Mike, go ahead and say hi.
Hey everyone, Mike Stefaniak. I'm a product manager on EKS. I've focused a lot on various networking projects in the past, including IPv6. You may recognize me from the public roadmap we have and putting out various comments and talking to folks on there. But it's great to be on the couch, and I'm excited to talk about IPv6 and the unique approach that I think we took in EKS compared to a lot of what's been done elsewhere in the community.
Yeah, it'll be awesome to dive into that. And Aproop, let's say hello. It's your first time on the couch.
First time.
Oh, you're muted.
And muted.
Hey everyone. So I'm Aproop. I'm an STE on the EKS networking team. I worked on the V6 implementation, mainly on the VPC CNI. I'm great to be here.
Awesome. And if you're joining us live, go ahead and say hello in the comments. I'd love to see where you're joining from and what you're interested in. Some of you who have been watching the show for a while may know that this isn't our first time talking about IPv6 with EKS. We've had a couple different shows showing how it would work in some cases. We had Container Days last year. It's been something we've been working on, and we really want to enable people, because the main problem that a lot of this is solving is every pod in Kubernetes gets an IP address. Your VPC, your subnet runs out of IPs, and those subnets can only be so big. So if you need to run 100,000 pods or something, that's all IPs. Like, you need to have IP addresses for this, and IPv4 subnets just don't scale as well sometimes. And so Sheetal, tell us what we've been doing with IPv6, just to kind of like, why does IPv6 solve that problem?
Yeah, I think Mike, do you want to get started? Probably that's a good segue, Justin.
That's right. We can jump into those. We have a couple slides here,
Yeah.
just to kind of go the overview. Pull that in.
Yeah, so like Justin said, the pod networking model is the key to the problem. When we launched EKS almost 4 years ago now, almost at our 4th birthday, we had a choice of which CNI to use. There were various in CNI, the container network interface, and as a container network interface, you implement the CNI spec as a plugin. And so we evaluated various community plugins that were out there, but we decided to build our own CNI, the Amazon VPC CNI, because we felt that the best possible experience for Kubernetes on AWS customers was to directly use the VPC. The way I like to describe it is that the VPC is already the world's largest, most performant, most battle-tested software-defined overlay network. And if you add an additional overlay network on top of that, you lose performance. It's harder to troubleshoot. In a lot of CNIs out there, we're taking that approach, either the overlay approach or the KubeNet approach, where you're just adding entries and route tables for nodes that join the cluster. And those approaches do work around the IPv4 exhaustion problem, but you lose all the benefits that you get by directly integrating with the VPC. And so we chose to build our own CNI plugin, knowing that as our customers grew their Kubernetes footprint, one of the problems that they're going to run into is running out of IPv4 addresses, because It's not the old days where a single app running on a VM takes up one IP address. You might have 50 pods running on a node, and each one of those needs an IP. So we always knew that the long-term answer for us was going to be IPv6. And so we launched support for IPv6 earlier this year. And as I mentioned, we think it's a somewhat unique approach. It's not Kubernetes dual stack, which is a feature I think that just graduated to stable in only the most recent 123 release. We actually are doing what Kubernetes considers single stack Kubernetes IPv6. So as far as Kubernetes is concerned, every pod only has an IPv6 address. But we did something unique under the hood where every pod unacknowledged by Kubernetes still gets the v4 address associated with the node. And we'll go into details on that in a little bit. But essentially, you get the best of both worlds. You're solving the IPv4 exhaustion challenge, but you still get v4 at the boundaries of the cluster. So you get v4 ingress and you get v4 egress. The way we do this is, again, directly integrating with the VPC, which already has supported IPv6 for several years now. You get simplified internet routing. You don't have to use NAT gateways. If you want to talk to something on the internet that directly uses IPv6, you just talk directly to it. Pod launches generally are going to be faster, and we'll get into the details why in a second, but there's no more dealing with warm IP pools or trying to carefully manage the number of IPs running on a node, because with v6, IPs are not a scarcity anymore. So, and then one more clarifying point. IPv6 in EKS is really a 3-layered answer. And what we focused on this launch is the bottom layer. The VPC that you're running your pods in is where we launched support for v6 in, and that's where the real pain point is running out of IPs in that space. In the EKS managed VPC, where the Kubernetes control plane endpoint running, that's actually still v4 only. And then the Amazon EKS endpoints like create cluster, delete cluster, those are still v4 only. We do have plans to add v6 support for those in the future, but everything we're talking about today is going to be in your side, in the VPC that's managed on your side of the cluster. Okay. So we have a few diagrams that go into how it works. I think Sheetal or Aparoop, do you want to go into some of the details here?
Yeah, I can. So we essentially, as Mike was saying, right? So we have the worker nodes running in the customer managed VPC, your VPC, and the control plane running in the EKS managed VPC. We have a cross-account ENI that facilitates, pods running on the worker nodes to be able to talk to API server. And this cross-account ENI is dual stack. So I guess the way I would like to put it is the entire east-west traffic within the cluster, by that I mean in-cluster traffic, is purely IPv6. So when a pod is trying to talk to another pod, or when a pod is trying to talk to an in-cluster service endpoint, a kubelet trying to talk to the local pod, maybe for some lifecycle hooks like liveness probe or readiness probe, a pod talking to API server. So the entire in-cluster traffic is purely on IPv6. And that's what we mean by a single stack from Kubernetes control plane point of view. But obviously we have public endpoint mode and private endpoint mode. So the kubelet, when it tries to talk to API server in public endpoint mode, it goes via the NLB, and that is still IPv4 only. And that's because of the NLB doesn't yet support instance targets for v6. And that's the reason why that flow is still v4. Other than that, the in-cluster traffic and both between the control plane and within the workloads is purely v6 only.
Right, and I think this slide shows in more detail what's going on the worker nodes.
Right, so as you can see, the subnets have both v6 and v4 siders. So when you launch a worker node in these subnets, the ENIs will get both, the node will get both IPv6 and IPv4 address, right? And the CNI, when as part of the node boot up, will assign a /80 prefix to the ENI, and the pods that are scheduled on these nodes will get an IP address or an IPv6 address from this particular /80 prefix.
I think one of the important points here is that this is what you're seeing here is one of the benefits you get or we get by working closely with VPC and building a CNI plugin that's integrated with VPC. We've been working with the VPC team for the last year and a half on this prefix delegation feature, which one of the primary reasons we built it is for container workloads, which have requirements to run lots of IPs. And if you're calling EC2 APIs every time you need an IP address, it slows down pod launches. And so this prefix delegation gives us the ability to assign prefixes to an ENI. So instead of doing individual IPs, you're now doing blocks of IPs for an ENI. And in the IPv6 world, that size is a /80. It's some very large number, and you're never gonna have more pods than a /80 running on the node. So it's just a single API call when the node starts up to allocate the prefix, and every subsequent pod that launches just takes one of those IPs. There's no need to call EC2 anymore to get more IPs. So it's much more simplified workflow as far as IP address management and allocation goes.
Right, I think, and that contributes to faster pod launch times too, right? So there is no additional EC2 API calls while we are trying to launch a pod, which can be on an IP4 mode. So on a V6, that contributes to faster pod launch times.
So just so I'm running through this in my head, I launch a node. So I have a VPC that has both IPv6 and IPv4. I launch a node, and that's going to get an IPv6 subnet assigned to it, basically. It's just like a bunch of IPs on this IPv6. All the pods are just going to use from that. So anytime my VPC says, hey, I need to route to this IPv6 address, I know it's on that node, and that's my next hop, basically, as a router that then routes to the pod IP address. How does the pod... Oh, go ahead.
That's correct. So we carve out a /80 from /64 and then assign that /80 to that ENI, and then pods will get an IP address from that.
And can you go over a little more on why using this approach doesn't eat into the IPv4 address allocations in the VPC, right? Because the VPC CNI has a couple different ways we can run it. We can do a /something on a node with IPv4. And we're doing that allocation now. At least that last diagram had that allocation showing. Is that also the case where we allocate IPv4 to the node, but the pods themselves don't get those IPs, right?
Correct. So the node itself, so the nodes are dual stack nodes, right? So because the subnet has both V4 and V6 enabled, so the node will get an IP address, IPv4 address. And that's the only IPv4 address we will consume for that node, irrespective of how many pods we run on that node. And we don't assign any IPv4 address from the VPC CIDR range to individual pods. So it's purely V6.
And that's what Mike was saying. The big difference here between dual stack Kubernetes and this approach is not every pod has an IPv4 address. But when the pod wants to go talk to something else that's IPv4, it comes from the node's IPv4 address.
Correct. So we can get this diagram. So we have two pods running, and obviously we have an IPv6 address from the VPC CIDR range. And we'll also see the 169 IP address assigned from the 169 subnet to individual pods. Right? I guess we went to.
So I think I think the next slide is pod to external v4, where we'll talk about the egress only approach. But this one is the simple case where if your pod just needs to talk to something outside the cluster that's v6, this is one of those sort of lesser advertised benefits, but can actually be quite powerful. Is there's no need to go through a NAT gateway to talk to anything on the internet like you're doing in a typical v4 cluster. If your pod needs to talk to something on the internet, it's generally getting routed through a NAT gateway or a NAT instance or some kind of NATing, network address translation. In the v6 world, if the v6 endpoint outside the cluster supports v6, it's just going directly out through the ENI, through the egress only internet gateway. There's no intermediate hop of the NAT gateway or the charges associated with that. It's just directly to v6 communication. So this I think is one of the potentially, depending on your networking setup today and how much traffic you have going through a NAT gateway, could be a really nice benefits cost-wise of moving to IPv6. So then the more interesting one is that this one we knew we needed to solve when we were building this feature, because we live in the real world. Many AWS services, including the EKS API itself, which I mentioned earlier, doesn't support IPv6 yet. I think Amazon.com, I'm not even sure, supports IPv6 yet. There's lots of things out there that don't have v6 endpoints yet. So we knew we needed a solution where pods inside the cluster could still talk to v4 outside the cluster. So this allows you to move to IPv6 and EKS without necessarily requiring every other dependent service in your organization and your VPC outside and some external API you use for them to support v6 yet. So yeah, you want to talk about the details here on how this egress CNI works?
Sure. So in v6 mode, we chain a second CNI plugin to the main VPC CNI plugin, and that kicks in when the cluster is running in v6 mode. It will go and create. So the VPC CNI will obviously assign an IPv6 address, sets up the required routing rules for v6 communication. The second CNI plugin will create an additional interface within the pod, and it will assign a link local IPv4 address from the 169.254 range, right? And that IP address is not as advertised anywhere else. So when you look at a get pod or a describe pod, all we see is the v6 IP address alone. And this is exclusively used when an application running inside a pod is trying to reach to some external service, and it tries to resolve the endpoint and it gets only v4 address, right? In that case, it will use the second interface with link local IP address to make a connection. And before the packet exits the node, we SNAT it with the node's primary IPv4 address, right? And if you're going, and from that point, it's similar to v4 cluster, right? So you're talking to some external service, you would go through an ad gateway, which will SNAT it again to a public IP address and so forth, right? So there's no ingress support, meaning you can't talk to your pod using its IPv4 address, because to begin with, it's not advertised anywhere, right? So the only way someone can figure out what's the link local IP address is to log into the pod and then do an IF config or something, right? And even if they do that, if they try to start try to talk to the link local IP address, we install a firewall rule to block that access. So it's purely egress only, and there's no v4 ingress allowed to these pods.
Got it. Oh, and I think maybe we missed, maybe I don't have the ingress slide here, but I might be missing that one. But anyway, yeah, one of the things I mentioned earlier, there's no more of this warm ENI target, warm IP target, because everything's allocated up front. And then before we get to the demo, just quickly, I guess I missed putting the ingress slide in here. But you also get v4 if you have something outside the cluster that's v4 or v6 and needs to talk to inside the cluster. We worked closely with the ALB and NLB teams to make sure that they fully supported IPv6 before we launched. So for a while, both ALB and NLB supported dual stack endpoints, meaning you could configure your load balancer to get a v4 and a v6 IP address and resolve to one of those. The feature that they launched late last year to support our launch is support for IPv6 targets. So you can now configure ALB and NLB to route traffic to IPv6 based targets. And the latest version of the AWS load balancer controller has support for IPv6. So if you have that running in your cluster with an ALB and NLB, it'll automatically advertise the IPv6 addresses of the pods behind your services to ALB and NLB. So that just works as long as you're running the latest version of the controller. It's all handled automatically. Okay. I would say before we get into the demo, Justin, any questions you have on any of that? How it all works?
So there were a couple comments about like downsides here of IPv6 and having the disassociation of the node is essentially your NAT of IPv4 that isn't exposed outside of Kubernetes or integrated in Kubernetes, at least the IPv4 addresses. That would be probably a downside. And then just general support of other things supporting IPv6 natively. Those seem like the two downsides that are like, oh, like this has some limitations, but those limitations, there's always trade-offs. All technology has trade-offs. And the benefits you get from IPv6 are essentially the biggest one is just don't have to worry about IPs, your pool of IPs running out of IPs in your VPC. That's great. And then the second one is possibly getting rid of like those, we call that like getting rid of NAT gateway charges. If you're going IPv6 to IPv6, it's just a direct route. Like the entire internet is one big IPv6 pool and you can route to anything, anywhere, theoretically, I suppose. But those are both huge benefits.
Right. I mean, if you're having multi-cluster service mesh use cases, now the individual pod IP addresses are actually reachable, right? They're global IP addresses. So that, I think that opens up the ability to use them without an additional overlay on top of it.
Yeah, and I love that the inter-cluster communication is all IPv6. I don't have to worry about translation or anything happening within the pod to pod. Those seem great. And there was one other thing that was called out that
I think the only other, so as far as the question was around downsides, I mean, I would agree that the benefits certainly outweigh. The one thing to keep in mind is that you can use an existing VPC with a v6 EKS cluster, but you do have to create a new cluster to use IPv6.
Oh.
We don't support converting an IPv4 cluster to an IPv6 cluster. Technically, it would have been possible. It would have added a lot of scope to the project, and we did wanted to use this. The other thing is that it's generally it's a bit of a dangerous operation. If you wanted to convert a production cluster from v4 to v6 on an existing cluster, we just think it's more work, but it's a better approach to create a new one and migrate traffic over gradually versus doing it all at once. So I'd say that's probably the biggest caveat you have to keep in mind when evaluating using IPv6 with EKS. You do have to create a new cluster and migrate traffic. You may also, depending on your responsibilities at your company, you may have to work with your networking team to make sure that the VPCs that you get allocated or use are configured for IPv6. You have the option to either use Amazon provided IPv6 space, or you can bring your own v6 space to a VPC, and either one of those options works with EKS.
Yeah, Mike, I think we need to also talk about the service sider. Service sider is also an IPv6, right? But it's from the unique local address range and not the GUA range of the VPC sider.
That's right. The Kubernetes services in a v6 cluster get randomly assigned a range from the essentially the RFC 1918 version of IPv6 is the private range, and that's where the service siders come from. I'll say we initially thought about what would it mean to have publicly routable service sider ranges. Like you potentially do some cool things like a global service mesh without load balancers, and it's just using kubeproxy. But there are some security concerns with that we haven't quite worked through. So it's if you are interested in that, I'd say open an issue on the roadmap. It's something we may consider in the future. But for now, the services in your cluster get essentially the private IPv6 space.
Right. So I think so with ULA, yes, it's private, but in a way, it's we have a 40-bit random generator number in between the address prefix, and that makes it very unlikely for the ULA ranges for the service sider to overlap across clusters. But yes, it's not truly globally unique.
And we cannot override that either today. It's just randomly generated range for the service sider.
Yeah.
Before we jump into a demo, I have a few more questions here from comments in the chat. And one is, if we can't route to the IPv4 address, can we still use ingress? Because it's using a ELB classic. Is ingress still allowed, and will traffic come from that load balancer to the pod, or at least the node IPv6 or IPv4 address?
So CLB or ELB Classic does not support IPv6 targets. So you cannot use the classic load balancer with an IPv6 cluster. You can only use ALB or NLB. Those are the only two AWS options you can use.
Gotcha. And Henry was asking, the node if the primary IPv4 address is on the node ENI, does that impact our pod density at all?
No,
No.
the
not
pods
using
are
that.
getting the slash coming from that /80, which is, I don't know, 13 trillion addresses or something. So I've yet to
Only?
see,
Come on.
I've yet to see a use case for 13 trillion pods on a node, but no, pod density is
Right.
not limited.
Yeah, so that's because the node is our NAT interface essentially to the world on IPv4. Everything beyond that internal to the node is node local. So we don't need to worry about that pod density. Cool.
Yeah, I think there is a max pod discussions that we need to have here, right? We just go with the Kubernetes standards, and a smaller instance types, we have it set for 110. And for larger instances, it's 200, right? Approve, if I'm not wrong.
I think it's 220 based on
Yeah.
for larger instances, and it's 110 for medium and smaller instances.
Yeah, we still have the max pod set, but it's just not for the pod density limitations.
And I mean, at some point, like an IP address isn't your maximum constraint, right? Like you have open file handles, you have all these other things you'd have to tune that are outside of Kubernetes control of just like, hey, like how much kernel tuning did you do on this to run 500 pods on here? Yeah. And Walter was asking about migration, but like we said, a lot of the new controllers are supporting this. So you're going to have to upgrade your controllers, which may only work with newer versions of Kubernetes. Anyway, ideally, we're saying and it launched in January, so this is 121 and above Kubernetes?
Yes.
Or
Yeah.
EKS?
Yes.
Yeah.
Cool. So I want to see it. I know Sheetal has a demo, right? Do we have any other slides or anything?
That was it for the slides. I think we are, yeah, demo.
Awesome. There it is. Sheetal, switching over to you. I know you have a cluster created, right? So let's walk through what's going on here.
Yeah, let me know when it is clear, Justin, because I do see both the screens overlapped for me here.
Yeah, let me remove that and pop it back in. I think your screen share got funky. Nope. Try and minimize your terminal and bring it back up. See if that refreshes it for us.
Okay.
Oh no.
Do you want me to unshare and share?
Yeah, you might have to unshare and share it again. We were a little late today because we had some sharing permission difficulties all around today. Hopefully this comes back clean. All right, see you coming back. Let's see. There we go. That one looks a little better.
Okay, so what we have done here, right? You will create the cluster as you are used to. We just have a new network config that is added. You will specify an IP family as IPv6. If you do not specify anything, by default, we created it in IPv4 mode, but you just say IP family as IPv6. I have already created a cluster for this demo.
That configs EKS control, right? So
this is correct, yeah.
Terraform or other ways have a different configuration, but it's similar naming.
Correct,
of what you
yeah.
need. Okay.
So if you're on a going through the console and the UI, and if you're a UI person, you're just gonna go ahead and on the next slide you will see the IP family being added. So this is where you will say I want to choose a cluster IP address family as IPv6. Yeah, and all the Terraform, CDK, and all of the APIs do support IPv6. They might just the flags might be a little bit different, but we do support it today. Okay. I'll just jump into the cluster that I have already created for the purpose of this demo. So let's get into it. Yeah, I did provision an older version, but nothing changes between the versions. Everything is same. I'm on the networking tab. You will see the cluster is created in an IPv6 mode. And the service IP range that we are talking about, the unique local address from the FD00, this is what you see it here. It is randomly generated for you. Let's kind of get into the VPC specifics that we talked about. So the VPC, has both IPv4 as well as IPv6. Basically, it's a dual stack VPC, right? And you will see 2600, which is from the global GUA range that is for Amazon that has been assigned. You cannot actually choose one. It is randomly generated for you. On the CIDR range is 56. Let's look at one of the subnets here, the private and the public subnets. So which one is this? Yeah, I'm on a public subnet. And if we look at the route table, you will basically see the route via the egress gateway, and from the private subnet. Justin, is it okay if I just
Yeah,
minimize a little
you can
bit,
zoom out a
because
little bit. Yeah.
because it's hard for me.
Yeah. Hide that screen. The sidebar too might help.
Yeah.
Yeah.
And for the private subnet, you see everything is going through the egress only internet gateway, and any ingress traffic is actually banned here. I have provisioned the node group already, so let's go look at the compute and the nodes. And I want to take you through how the node gets both IPv4 as well as the IPv6.
And this is supported on managed node groups, self-managed node groups, and Fargate?
Correct. That is correct. Yeah. It's supported Fargate as well, where in Fargate, like every pod is itself contained small, virtual machine and the instance, right? So you will have both IPv4 as well as IPv6 assigned for the Fargate pods.
Yeah, I'd say that's actually an important point, is you don't get the IPv4 exhaustion benefits with Fargate because of the one-to-one mapping between node and pod. You're getting that benefits on EC2 because you might have 30 pods on one node. In Fargate, it's still dual stack nodes, just like it is in EC2, but it's only a single pod per node. So you get you can connect to v6 endpoints outside the cluster, but you don't get the same IPv4 exhaustion benefits. To really solve that, EC2 recently launched support for v6 only subnets. I think that came out slightly after our launch. Eventually, we will support v6 only subnets. And in that case, you could run your Fargate pod that only gets a v6 address. And if you still need to talk to a v4 endpoint outside the cluster, EC2 also recently launched a v6 to 4 option in NAT gateway. So you can have a managed 6 to 4 translation instead of doing the node local translation that we do on the EC2 instances today.
So once my traffic leaves the network, my now interface to an IPv4 address is at the VPC NAT.
Correct.
Cool. Yeah, we can move that border for where we want to do that translation depending on what type of lookups we're looking up. If the workload says, "Hey, I need to go talk to some host," it only supports IPv4. Either the node's going to translate that, or the NAT's or the VPC subnet's going to translate that. Cool.
Okay, so as we see here, you just see one of the IPv4 address assigned to the node primary interface. And for the ENI, you will just see exactly one IPv6 prefix basically assigned at the start time of the node. And as we already said, /80 is 10 to the power of 14. So you have enough IPs available for pod assignment, and we don't necessarily need to make any other additional calls. I'm going to go ahead and basically connect to this node, and we will, okay, so let me pick up another node actually. Yeah, I'll just go through one of the node, and we will walk through the host local implementation on how it works. I'm just using SSM to connect to. Yeah, if you, I'm just opening up AWS CNI configuration file, and you will see egress only v4 CNI has been changed to our AWS CNI, and host local, and from the non-routable 169.254 host local space has been used here. And with /22, there are enough IPs available, 1024, and any of the maximum instance type that we have, you will not run into any of the IP limitations with the host local CNI that has been changed here. I'm gonna go ahead and try and run some workloads now. Let's get into the actual testing. So I have already deployed few pods, just the sample pods. And as part of this exercise, I'm just gonna also do a sample pod. You don't do any additional annotation, or you don't need to add any additional annotations, just like the upstream Kubernetes. What you do is just the plain and simple pod definitions without any annotations. So I'm going to go ahead and apply this. Let's see if the pod, yeah, it's, while this pod, okay. I am executing into the pod just to observe the IP assignment here. You will see E0 on IPv6 address being assigned from the VPC CIDR range, and you will also see an IPv4 address being actually assigned to the pod as well. This is local to the cluster, and we are not going to use this IPv4 address for any pod-to-pod communications, only egress IPv4. We just make use of this IPv4 address. As per the ingress, I have a sample dual stack application here, and I am actually creating a service type like ingress. And here you will specify, I'm just saying it's a target type IP, and address type is a dual stack. And this allows a load balancer to be created with both IPv4 and as well as an IPv6. The ingress is configured as IPv4 and IPv6, but all the pods and the target groups for this load balancer are only going to be IPv6. Let me go ahead and apply this. We will see the target groups in action.
Okay. So, and in this case, the dual stack is referring to the ALB itself. That
Correct.
It needs IPv4, IPv6, but none of the pods behind the service are actually getting those two IP addresses, or at least they still get the 169. That's a little bit like it's a local IP address to the node, but it's not using any IP address in the VPC.
Yes, that's correct, Justin. Yeah, I had already provisioned one of the a service with type load balancer, and what I'm trying to do here is, let's go ahead and actually observe this in a console, and we will actually see and monitor the targets as well. Let me go to EC2 console. Yeah, load balancers. This is the load balancer service type that I have created. Yeah, and if we go to the target here, basically all of the targets that you see are just IPv6. The IPv4 address, which is very local to the pod, and the cluster is not advertised anywhere. The NLBs and the ALBs will have the targets as an IPv6 targets. So what I'm going to do here is I'm going to log exec into the earlier pod that I have created and try to observe both the IPv4 and as well as the IPv6 egress. I'm just going to go ahead and curl to this public endpoint, and default route it takes is an IPv6, and you will see that it is able to resolve to one of the service that I'm running. And if I go ahead and use the IP v4, what I'm doing is I'm just printing the pod IPv4 address, and I will try and curl using this IPv4 endpoint, and that shouldn't be supported from the pod IP actually. Let's see if I just specify an IPv4. Yeah, it should be blocked. So yeah, I'm executing to the pod and then trying to use IPv4. It shouldn't connect, but if I try and connect using the actual load balancer IP, it should take the route of IPv6 and it should be able to connect. So let's see, specifically mentioning the IPv6. Yeah, it will resolve. And the pod is this IPv4 is the pod IP. I'm just printing the pod IP, and if you just ping, all the traffic will be blocked at the pod level. And the same, you can use the IPv6. That should work. So the pod to pod, any east to west is all IPv6. IPv4 will be blocked at the pod level. And let's see the ALB that we have just provisioned. What is the state of the ALB if it is running? Yeah, I'm just trying to dig the endpoints. You will see pod A and then A records being created. And if we go and observe the load balancer that we just created for the ingress, and this is the latest ingress load balancer. And if we
The popover stuck on your screen a little bit.
oh, let it refresh, or I can share an
I don't know if it'll catch up at some point. I don't know if anyone else sees the same. I see half of the pop up of the search.
Okay, let me stop sharing and share it back again.
Otherwise, you have to like erase it with your mouse. As your mouse moves, the white was showing through.
I know it's very weird today.
I saw another question pop up too while we do that. So in this case, each node gets one ENI for both IP addresses, right? Because we can assign both IPs per ENI, and so we're only using one ENI per node.
Yeah, that's the good observation as well, because we just assign a prefix /AT and we have enough IPs available. So one ENI is what we are using here. Okay, so if we go to the targets, all of the IPv6 targets are to be seen for the latest ingress service that we just provisioned. Let's go ahead and observe. I am running on an IPv4 network. So the IPv4 network should resolve to the IPv4 and IPv4 IP of the load balancer basically, right? And that should work. And internally, it is actually directing all the traffic to the IPv6 pod IPs.
The screen share got a little messed up again. I see part of the app now, but it's catching up. I don't know what happened. Again, it was technical difficulties earlier today, so I'm glad we got this mostly working.
Yeah, I'm really sorry, guys. This is
it's not. Yeah, it's
very unexpected, but
2 years into working remote, you would think a lot of this would work out well now, but there's still problems.
Yeah. I think pretty much we have covered it all from our demo perspective. We can take any questions, Justin. I do see there is one more question that popped up while IPv6.
Yeah, let me switch over here. Sec. Where'd those comments go? So the only one ENI question was asked. It's one network. Basically, if you plug in a cable into any computer, you can have two IP addresses over that same cable. ENI works the same way, where it's essentially one network interface into the the EC2 instance, one cable, but you can have both IPv6 and IPv4 addresses. Just my home network has IPv6 for no reason whatsoever, but it's there, and I only have one cable plugged into my laptop. So it works the same way, where each cable can get both addresses. Each pod is also doing that. The only difference here is one of the IP addresses, the IPv4 address, isn't routable to other pods.
I think the real reason why we only need one ENI is actually the prefix delegation feature, because if we supported, so that's actually another point we didn't discuss. Are there any like limitations to be aware of with IPv6 and EKS? We only support IPv6 in prefix delegation mode, meaning the /80s assigned to an ENI. We don't support it in the secondary IP mode, where you're just allocating individual v6 addresses to an ENI. And so prefix delegation is only supported on Nitro instances. So if you're running like older generation, like I think generation 4 and older instances, that won't work in EKS clusters. And so because of prefix delegation, we don't, in the single IP secondary mode, I think a single ENI, depending on the instance type, might get 10 IPs. And when you reach that limit, you have to allocate another ENI to the instance. And eventually, each instance type has a limit on the total number of ENIs. Because of prefix delegation, where we're allocating a CIDR block to an ENI, there's no need to allocate multiple ENIs per instance. So that's the real reason. So even if you're using prefix delegation in v4, generally you still only have one ENI per instance. I think in v4 it's /16 or
/28.
/28 per prefix. So you might have multiple prefixes on the ENI, but generally you still will run out of other CPU, memory, other kinds of resources on the node before you need to allocate more ENIs. So the single ENI thing is really because of prefix delegation. It's not really related to IPv6.
Yeah, and there is another question. I think the subnet sizing or the link local IP.
Yeah, for the link local, I think we mentioned it was 1024 IPv4 addresses locally, right?
That's correct. It's about 1K IPv4 per node. And right now,
the subnets are actually 64. If just the IPv6, the VPC subnet size is /64.
That's correct. So we get approximately 2 to the power of 16, so 65K/80 pixels per subnet.
I think Henry had another question where a lot of us early on in IPv6, like I had this concern all the time, like why are we just wasting all these IP addresses? And then you just realize like how big IPv6 is. It's not like, oh, it's twice as big. It's not 10 times as big. It's like massively overly just like, yeah, no, if every atom had an IP address, like IPv6 is still enough.
Yeah, we did. I mean, we did some math early on with VPC team to get to the /80. It does seem like waste, but again, like in the context of IPv6, it's actually not that big.
And maybe improvements might be coming further, but yeah, /80 is fine, I guess, for today.
I think like, maybe your grandchildren might have to think about it, but it's not something, we're not going to run out of 6 anytime soon.
Yeah, that's another interesting question actually there. Justin, if you want to pull it up on the screen. Yeah. Mike, do you want to talk about CGNAT space and the challenges that we have today? 164.
Right. So one of the not workarounds, but features we added to the VPC CNI before we launched IPv6 support was this feature we call custom networking, which really just means adding additional CIDR blocks to a VPC and running your pods in that CIDR block. And VPC allows you to add, I forget the limit, but some number of additional CIDR blocks to a VPC in the CGNAT space. And you can run pods in that space. So if you're not ready to move to IPv6 yet, that's a feature you can use to get more space for pods while still utilizing IPv4. In the v6 world, that goes away. There's no custom networking anymore. You just get the huge /80 on the worker node. You never think about IPs anymore, and you don't have to do any additional CIDR blocks or things like that.
Cool. I mean, this was super eye-opening. I love that we got so many questions and people interested in this. If you're trying it out and want to see how IPv6 works, again, Sheetal, is that config for the example? Is that in the EKS control repo, or do you have that somewhere like as a GitHub?
Yeah, we have a blog, right, for IPv6 blog that the case control configuration is out there, and that's a good blog to follow as well. And whatever we talked about, the technical details and the implementation details today is covered in the blog post too.
Cool. Yeah, and Delboy, yeah, that is the problem right there is you do need to support IPv6 at these different levels. So once you get a VPC with IPv6, then you're ready to go start creating your clusters and getting those pods in there. So, but I think that's it for us. Thanks everyone for joining. A couple housekeeping things. Next week we're doing container days. We have 4 days of streams we're shifting our time. So if you're joining live, we're doing it for KubeCon EU. So we're going to the European time zone. I will be going in person to KubeCon EU. Mike, are you there?
I will be there. Yeah.
Yeah, I know you'll be there. But Sheetal and Aproop, I don't think you are both going, right?
We will be joining virtual, so
Sweet.
we'll see you. Mm-hmm.
Yeah, but you will be. A couple of you will be on the container days next week, so join in. We have a bunch of different segments lined up, all different talks, new features, a lot of stuff we're working on. But then also we'll be at KubeCon EU as well. So if you're joining for next week, just know that we're shifting time zones there. But everything will still be on YouTube, recorded after the facts. We're going to split them up and post them afterwards in individual segments. So you can still catch it on YouTube if you want to subscribe there. If you don't need to watch live, all the content is going to be available. So. But yeah, thank you so much. We are doing another little overview of IPv6 next week for anyone that couldn't come today or hasn't watched this show. We'll have a small segment there as well. So come join. You can subscribe. I should have got the link so that I could share it. But anyway, find us on leave comments on the YouTube video. I'm on Twitter. Sheetal's on Twitter too. I do not remember. It's Josie. No, it's I don't remember your handle right now.
Yes, it's Joshi. Yeah.
Joshi, yeah. I was like, I know, I can see it in my head, but okay. So hit us up on Twitter if you have questions. Mike's on there too. We are also doing a Twitter space for EKS ideas and things you want to see in the future. Amazon's working on what we call OP1, which is kind of all our big initiatives. So that's later this week as well. So find us on Twitter, give us some feedback, and let us know what you think of IPv6. Thank you everyone for coming, and we hope to see you. There's no other shows this week, but we'll see you next week or maybe in person at KubeCon EU. So, bye.